In this video, we're going to continue on with looking at logarithmic functions. So let's take a look at continuing to evaluate logarithmic functions. So looking at this one, remember our idea is we want to get this number, this input, to be the same base as the log. So we do know that base 1 over 4 is 1 over 4 to the first power. So you can remember that if this base is the reciprocal of this, that this is going to kick back a negative exponent. You can also actually rewrite 1/4 as 4 to the negative 1 power. So then log base 4 of 4 to the negative 1 is negative 1. So again, if you want to remember reciprocal bases, that's going to kick back a negative exponent, you certainly can do that as well. So again, we've got kind of a fraction here. So we're looking at a base 4 log. Okay, so this logarithm has a base 4. So we want to try and write this as a power of 4. So we've got log base 4 of 1 over, and now again, we want to rewrite 64 as 4 to some power. So this is 4 to the third power is 64. So then this base here is the reciprocal of 1/4. So 4 and 1/4 are reciprocals. So this is going to kick back a negative version of this exponent. So log base 4 of 1/64 is negative 3. So if you wanted to, again, think about rewriting this as a base 4 instead of leaving the reciprocal, so this 4 to the third power could come up to the top, in which case the exponent would switch to a negative exponent, and then you can see the log base 4 and this base canceling and getting back that negative 3. Natural log of 1 over e squared. So the thing to remember here is that the base of a natural log is e. So now we see the reciprocal of that here. So the ln of 1 over e squared is going to kick back negative 2. Seeing radicals in this one, okay, so we've got the natural log here, which is a base e, which is good because we've got an e here. But now we want to rewrite this radical as an exponent, okay, a fractional exponent. So remember that anything with a radical power, so here's the property from algebra. So this will stay the exponent, so the n will stay the exponent, okay, and so that'll stay here, and then this root will come underneath that exponent. So the mth root of e to the n is e to the n over m. So in this case, this 5 would be our bottom number, and this 4 would be our top number. So we actually have ln of e to the 4/5 power. And then we know that the natural log has a base e, so this natural log and this exponential base e cancel, and so we get back 4/5. And then this one, what's the value of log of the 4th root of 1,000? So remembering that a common logarithm that doesn't have a base listed is just automatically a base 10. So now you'd want to make sure that you rewrite this number underneath the radical as a base 10 power. So we've got log base 10, and then 1,000 is 10 to the third. Then you can use the radical rule to put it as a rational exponent. So we have log base 10 of 10 to the 3/4 power, moving this root underneath that exponent. And so then the base 10s would cancel and you'd get back 3/4 as your answer. And then looking at a couple rewriting logarithms as exponential functions. So this one says just rewrite the logarithmic equation as an exponential equation. So remember that you need to take the base. Okay, so this log as a base 10. And the exponential function will have that same base, but now this input and output will switch. So we'll have 10 to the third equals 4x. So base stays the same, and then you switch the input and output. So 10 to the third equals 4x. So again, find the base, that will stay the same. So we'd have an x plus 1 base. And then the output becomes the exponent, and then equals this input. So x plus 1 to the 6/7 equals 4x. Looking for the base here on the natural log, the base is in e, so our exponential base will stay the same. Output becomes the input. Input becomes the output. So then those would be the equations that you would end up with. So logarithmic form, exponential form. So 10 to the third equals 4x. X plus 1 to the 6/7 equals 4x. E to the 3/7 equals 4x plus 1.